So yeah, today I'm working on implish. Implish is a programming language that I'm designing for a course. It's meant to be pretty small, something around the size of a Scheme or a Lisp, a homebrew Scheme or Lisp um, that you could do in the course of a few weeks. Um, and in fact, it will be a programming course, a programming challenge anyway, with some videos behind it saying what it's all about and what's interesting about the language. Uh, it's something. Whoops, all over the map with it today. Yeah, so it's on GitHub. It's tangent code implish. There's not much to it yet. Right now, I have a bunch of documentation for things that I think are sensible to have in a language. But what I'm picturing is something a little bit like this. So it looks a little bit like kind of a blend of K and Smalltalk and Rebel or Red. Basic idea, echo hello world. You've got keywords and you've got arguments. So this is a function that takes an argument. Everything is separated by spaces. An assignment. Red has this notion of what would they call it, but like refinements. And so this would be in a refinement to the input function. So the prompt is what is your name, and it's refinement to input, which is kind of like a keyword arguments to a command line function. That is not at all a coincidence. That is, I intend to make this something like even today. I had some reason to like write a small bash script, and like I was like, I don't like this language. I've never liked bash. I find it very strange to do like an if statement because it's you have to it only has this idea of like executing an external function, whereas why does it have to be that way? So kind of the idea for implish is that it runs on top of everything. It can be your shell. It can be something that runs in a web browser. Hooks into everything. It will have a pipeline kind of syntax like a shell, but it will also have the ability to just do basic programming. So a lot of K-like syntax here, but also a mix of K and like I said, Rebel. And my own little thing. I've always wanted to have a language where abbreviate if and elif, or else if and else even further than they usually are. So here's FizzBuzz, the comment. I think I did it right. So if it's not if try in range 100, actually that probably should be an exclamation point. If not I mod 15, then write FizzBuzz. Elif not I mod 5, then so if I mod 5 is 0, and it's divisible by 5, so write buzz, and if it's divisible by 3, you write fizz, and else you just write the number, fizz buzz. And then every 10 or so, echo there's a bug there. It's gonna put one after the first number. It should say if I is greater than 0 and I mod 10. Echo to produce a new line. Else okay being the empty program. And then this is a Mandelbrot set. I don't know if this is actually going to work. This is all hypothetical, by the way. This is all just like what I'm aiming for. This is a Mandelbrot set. Some K code that I wrote as an example, and then I've done some minor changes to convert it into what I think might. Basically, I changed the comments, and then a couple of these I changed it a little bit. I think some of these are. It's going to be very much like K, but K embedded in a Rebel like syntax. We'll see. That's how I'm thinking of it right now, but it could be wrong. But one important point. I'll just go through this list. I'm not going to read the whole thing because it's there and you can read it for yourself if you want. It's on tangent code, implish. But basically, as of today, as I'm writing on this, it's meant to be ultra portable, so it's going to run on atop different things. So it could run in a web browser atop JavaScript. So that's why I have this virtual machine called the B4 VM that you implement in different languages, and then you can run other languages on top of your main languages. I'd love to have a language that I can use in like Blender and in my shell and so on, and all these different places. So that's that. And then then they would be able to talk to each other over whatever mechanism that's provided in the particular application. You should be use it to be able to talk to other applications in like a network, all using the same syntax. What's that in a second? So it's an imperative core, blah blah blah. Something about functional programming. Everybody wants to do that, and then they get rid of all the imperative stuff, but or try and cram everything into a functional language. But maybe there's a better way. I don't know if there's a better way, but there's a different way. In this book, which I am very fond of, A Practical Theory of Programming. It's free. You can read it right here. And he's even got a video course about it. His website somewhere. Yeah. He's got videos up here. Really, really good thing. And it's all about like proving programs, but like imperative programs. So he's got a whole theory of like, mathematical approach to programming. And I've always wanted to, ever since I saw this years ago, I've been thinking if I ever made a language, a serious language, I would start with this. So that's why it's called implish. It's an imperative language. So imp is for imperative. But in his little algebra of languages, you've got okay, that's empty program. You've got assignment, and actually he talks about. Look at this here. Basically, I didn't really fill this in yet, but basically he talks about specifications, right? A specification is a binary expression that's true or false, and it concerns name variables that are before and after the operation. So an increment might have a name variable called n, and if n is assigned to a number, then we're going to do this. Otherwise, we're just going to do nothing, because plus does not. If it's not a number, then what does plus mean? But then the idea is that n prime is equal to n plus 1. So n prime is like the next iteration of n, the next value of n after the program is run. And this can be abbreviated by n is assigned n plus 1. Yeah, that's it. So this is a specification in his world. This is my syntax for his kind of math. But it's just a Boolean expression. So this is literally, a true or false statement. So, you can evaluate whether n prime is equal to n plus 1 or not. So you know what n is, and then you know what n prime is. You can look at it and you can see whether that's true or not. And then if it's true, then the specification has been filled up, implemented, and that's a program. A program is just a program is a specification of behavior, and then it's either true or false. So it's because the specification is either true. And in particular, you want to say that like the program refines or implements the specification. And so one way to implement it would be like inc is, you would just do the assignment. Like this actually is a program, even though it's a specification and a program, not all specifications. Anyway, that's a little more theoretical than I wanted to get into, but like that's kind of the idea behind it, and I plan to dive into that a little more as I go. And so part of the reason that it is code as data, so it's homoiconic, is that you want to be able to read the program and like evaluate it and actually do proofs and things like that. I don't mention that here, but it's very so it's imperative. It's got these very simple core constructs: do nothing, like pass in Python; assignment, which is shorthand for this, where with all other variables not changing. So then sequence is you are if P and Q are programs, and this is the sequence of P and Q is a program. And then if some binary expression, do this program, else that program, that's a program. And then while B is true, do a program, that's a program. And these are all very simple to explain in his math with just like really, really simple symbolic manipulation. While is a little more complicated because it does involve recursion, but he has like a whole chapter on how to deal with that. So the point is you can write proofs with this, the way he's laid it out, and so I wanted to explore that idea. And this says that these are implemented, but this is not true. These are just like things that I imagine implementing. You would implement for loops and repeat until and that kind of thing. Oh, this is a comment if that's not. Of course, functional programming is great. So, you know, wherever possible, try to support purely functional referentially transparent code, which means things like, you know, basically referential transparency means that like you're not like if you make the same function, it should have the same answer every time. If you make the same expression, it should have the same value every time. You don't have too much hidden state flying around. All right, here we got band notation. So x equals 0, 1, 2, 3, 4, or bang 5, same thing. And then we want to say like check equality so that I'm worried that this is going to be ambiguous to parse this. I might not be able to parse this the way that I have it here. Might need to be parenthesized or something. But basically, this has two arguments. So you have the first argument and then the second argument. And then the first argument and the second argument doesn't matter what order they're in. This is a lambda. This is how you define a function. You just make a lambda and then you give it a name. So it's anonymous until you give it a name. By default, these are the arguments. But if you don't pass any arguments, you can refer to x and y, and those are applied, just like in K. X, Y, and Z, I think, are applied in K. This is a single token, and this is an expression. So that, I think, is not ambiguous. That's how you can do that right now in like red. This I'm not so sure about. I think this would be unambiguous. This might actually be ambiguous because this could be infix. This could be 10 plus plus. Right. So I think this is actually wrong. This one is Anyway, you also have projection like in K. This means this is a partial application to the first argument or both arguments, and then this can be applied the same way. So you can use the juxtaposition, or you can use bracket if it's attached to the word. Code is data. Strings are double coded. Triple backticks like in Markdown. Numbers look like numbers. Parentheses, square brackets, curly braces form nested structures. These are nested comments, so that's a single token. Anything in between these is a single token. Everything else is just symbols separated by white space. And I may change that slightly a little bit because like I want to be able to say like bang of 10. Where do I do it here? Well, like bang of 5 here. I think you ought to be able to remove that space. Maybe not. I don't know. But like basically, if it starts with letters, then it can contain anything. But if it starts with a symbol, then you know maybe when you hit a number or whatever, then it stops. And by symbol I mean punctuation. Okay. Where was I going? Yeah, so it's a data structure. It's a data format in that sense, kind of like Lisp. In fact, you could stick a JSON in here. It'll parse JSON if I've done the rules correctly. But like in JSON, you'll have like if you had a list of 1 and 2, it would be bracket 1 comma 2 end bracket, and in in implish here, that would be a list of 3 items, a 1, a comma, and a 2, because the comma is not, it doesn't use that kind of punctuation. But then you could further process it and then get the same data structure that you would get with JSON. So it would do some of the parsing of JSON, and then it would give you something back. And I think it would parse pretty much. I think it would parse pretty much anything you throw at it, but it would have trouble recognizing comments because there's no, it expects this to be a comment. I chose this specifically because it hardly ever appears in a programming language. I grepped like all my my Git repositories, and I used it in J and I used it in Haskell once, but that's about it. And that was because I was defining a custom operator in Haskell, and then J just has weird syntax. I think that's actually does some. This actually is some kind of like functional composition in J. It's like an error handler. Whatever. You can't not escape J. J uses every symbol. Anyway, so then load will read this data structure, and then you'll get it. So then now you can manipulate the data, and just like in Lisp. But unlike Lisp, instead of a list-oriented language, it is a array-oriented language. So you can have arrays of symbols, just like in K. So maybe a homoiconic K or Nial would be very similar to what I'm doing, but like small. And then also there's this concurrency and object orientation thing. So like I'm using this right now as a one of the things I wanted to use it for was to have this notation to talk to implementations. So I've got a test suite, right? I'm making courses, and the courses are programming challenges, and we give you a test case. Like I actually have one right here for implish right now. So my very first test for implish is that if I say echo hello, it should produce hello. All right, and the idea is that this is completely detached from it's not a unit test. It doesn't know what function to call inside your program, because you're free to do whatever. That part is up to you. It's just a specification, and we run your program, and we send it some input, we look at the output, right? So I've got a challenge like that called LearnTrist now, and in that I made a special like domain specific language for describing Tetris, right? So it's a challenge to build a Tetris game, and I want to make a bunch of challenges like that, but I don't want to make a language for each one. So I have to have some standard way of like sending data to any program and getting any result back. And so that's kind of the idea of implish here. I may do something that's like like an RPN reverse Polish notation stack-based kind of thing, using the same this same like code as data syntax, because that's a little simpler to do. It's simpler for people to implement, because you have to implement this to plug your language into the thing, and so you can do RPN very quickly, but the the evaluation rule for implish is going to be a little bit more complicated. So I don't know how difficult it is yet. I know I can make the 4th version, and I'm going to have a video like how to make a language in an hour. So that's very simple. This one is going to be a little more complicated. So I'm thinking actually maybe I write the tests here, and then I have this compiled to translate itself to the first Polish notation that's easy for the people to write their tests. I don't know. I'm just building this. I guess I should also say, like at the end of the course that I'm building, I start with a virtual machine. You're going to build a Lisp. You're going to build a Forth. You're going to build a Pascal, and at the end, you're going to build this language, like a more, I wanted like a dynamic language, a Lisp or a Scheme or a Logo or Rebel, Red, that kind of thing. Something that would go at the end, but I wanted my own spin on it, and so this is the only thing I hadn't really nailed down in the course, right? Like I know what the virtual machine looks like. I know what the Pascal thing looks like. I know what the Lisp looks like. I don't know what this looks like. So this is why I'm building this right now. But one thing I did have a I don't have the maybe it's under docs. Yeah, a long time ago I wrote. Oh, it's not even here. I didn't check it in. Anyway, just the idea that concurrency and object orientation. I've always thought that they were kind of the same. Like object orientation really ought to be a concurrency kind of thing. And Alan Kay, the guy that invented Smalltalk, said, I thought of objects being like biological cells and or individual computers on a network, only able to communicate with messages. And that's kind of how I see this. So, if you take this idea that you're going to do this imperative, math to describe your programs and write proofs and all that, and your programs are changes to variables. You don't want just like a million variables in your program. You want to break it down into little pieces. So to me, that's an object. But instead of the traditional thing where you have a class and whatever, it's just a program running on a different virtual machine, and you have a bunch of these virtual machines. So kind of like the Erlang kind of world, but like a procedural Erlang, if that makes any sense. And so if you want to send a message to it, well, you just send one of these chunks of data that is a program, right? And then it evaluates it. Only it has slightly different words in its vocabulary, and that's its methods and whatnot. So that's kind of my concept of both concurrency and object orientation. And then also, of course, because this virtual machine will be implemented, it'll be very small and very easy to implement in a bunch of different things, then conceivably, you'll have like also virtual hardware, right? So like a WebSocket might be a piece of virtual hardware. So in theory, you might be able to get like Blender talking to your web browser or something like that if you had a thing in Python. Blender is scripted in Python, and you had a thing in JavaScript or whatever you're running in your web browser, or WASM or whatever, and you have that same virtual machine, which is very small, and then you have this language running atop it. Well, you could send messages back and forth between whatever you want to connect. And I know you can do that now with like plain old HTTP, but here you have, it's just a way of doing it. It's just a way that I thought would be interesting to do, and you would also have the same tools on each side. You would be able to have your whole tool set for all the things you want to do. Like today, like I'm writing this in JavaScript, and I said, okay, I really need a test suite. And I went looking at JavaScript test frameworks. I was like, why am I doing that? Why don't I just use the test framework I have that I'm using for these courses anyway, and just write the tests using my test thing? Well, eventually that tool ought to be in this language, and so then it's running on the virtual machine. Just everything, just like the tool set you can take anywhere to whatever language you want to visit. So that's the ultra portable line at the top here. That you shouldn't have to throw out your whole tool set every time you try a new tech stack, and that way you can still continue to explore and learn. And I kind of picture it like the Borg. You assimilate every tech stack you want, and you just latch onto its head, and now it's part of the collective. I don't know. Star Trek reference. Anyways, gradually typed. I like type annotations. Sometimes I start with them, sometimes I don't, blah, blah, blah. I like to think in terms of type sometimes, and sometimes I just want to experiment with stuff, and so, gradually typed. And then it's going to be database included. It's going to be run on, you'll have access to SQLite, at least as a piece of virtual hardware. Yeah, here's some examples, blah, blah, blah. Here's FizzBuzz. I think I did this earlier, and then Mandelbrot said this is very K-centric, and probably this will be slightly less cryptic by the time I'm done with it. But only slightly. It's meant to be an extremely expressive language. All right, so blah, blah, blah. That's it. All right, anyway, where I'm at, I've got a parser for this language. Or at least the, okay, these are the symbol types that I recognize, or the, the token types I recognize, and there should be one called list here. I hadn't gotten that far, so that was what I was working on today, and it's been just a really hectic day with the children, and so there you go. And then the reader here reads all these things, and I'll just show you what it does right now. If I go to diver implish, and I just say it's all written in JavaScript. If I say node imp.mjs JavaScript module, then it loads up this little prompt. Yeah, kind of slow there. Where's int.mjs? So it's using this prompt thing. I don't know if I'm going to keep that around or not. But you say 1, 2, 3, or I'll paste in an example, right? So how about this? Let's see what this does. I don't think I can use a new line yet. Let's see what this does. So this is just going to be parsed as a symbol, a symbol, a symbol, and a string. Symbol, 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 string. And so this is actually like an assignment syntax, but as far as the first layer parser is concerned, that's just a symbol because it's a space separated symbol. And so the next layer is going to look at that and say, oh, well, that symbol has a colon at the end. So it matches this pattern. So it means assign something to this variable name or to the word name. And input is going to be a built-in function probably to read input from the prompt. And then this will be a refinement to that. And then this will be a string passed to that refinement. So that's kind of the idea. I don't know if that's actually going to work, but we'll find out. So right now, the REPL, as it were, is actually a read print. This is it's a RP loop, read print loop. There's no eval step, and the print is terrible. So I thought I would fix the print first and try and get this to round trip. So let me do that. So I guess I'm kind of moving into coding here, talking for 2 hours, 1 hour, actually 26 minutes. But, all right, so just a little review of where I'm at so far. This is actually something I had some code lying around for. It was actually called implish from like 8 years ago, and I just dug it up. I turned it to since yesterday. I turned it into. It was all it really was like the start on something vaguely similar to this idea. I've been thinking about this for a long time, and I cleaned it up a little bit. So I turned it into modern ECMAScript ES6 syntax using modules, and yeah. So the basic idea is, I guess first we have the core. So the core data types, we've got this OK thing, which is the empty program. We've got a list of types. This is just a dictionary mapping strings to themselves. Mostly so I can say t dot list or whatever. We have a sim table, which just uses symbol function. Actually, symbol has key for, and I could probably simplify this a little bit, but whatever. So basically, this is a thing that maps a string to a canonical symbol. So it's like interning the strings, I guess. I don't know if I really need this, but I wanted to mark something as being distinct from a string. So maybe I don't need this, maybe I do. I don't know. But whatever. It's 4 lines, 1, 2, 3, 4, 5 lines of code. Tree builder, and then the tree builder is something that builds one of these nested structures. So it's got a current array that we're applying to. It's got a root, and then here is the root. Here is the context we're appending stuff to, or emitting things into. It has a stack, and the stack is to keep context. So whenever we emit something, we just put it into the current here. Whenever we say node, that creates a new layer of the, a layer of nesting. We push the current context or the current array onto the stack and make a new array to start adding stuff to. And then when we're done with the node, that's the opposite of node and then done. These are start and end, right? Then we pop the old thing, push the current thing onto the old thing, and then make the current thing the old thing, right? So, or we point the here, the where we're emitting to the old thing, and that's works. That's all you need to build a tree. Kind of handy little pattern. And so once we have those two things, then we can start looking at the reader, and we just have a buffer of strings, so that you can do this incrementally. You can type 1 line, and then like in the prompt here, if you type, oh, you can, yeah, that's right. Hang on. So in the example, I said I didn't know if you could do multi-line string, but you can. If I do this, and I just paste it in here, yes, paste anyway. So you see the first one immediately said it's a symbol. Okay, that actually is wrong because it's not a symbol. But the second one, you can see that the prompt changes to this, and that's because it knows that this bracket is open. And so as long as the bracket is open, it's still going to let you incrementally add text to the, what am I trying to say? Incrementally add text to the buffer, and it just keeps pulling stuff out of the buffer. So what it does is like it'll parse this token and then append it to a list with, with a marker here saying it's a symbol. It'll say sim symbol 4. And then it says, okay, well, I matched that one token, and then the rest of it, just put it back in the buffer. And then the next time around, it grabs the next token and so on. So that's kind of how it works. It matches one token at a time, and we'll see that in a second. Oh, I'm missing it. No. That matches, that matches, that matches, that matches, that matches, that matches, matches, that matches, that matches, and that matches. And then this matches that. Okay, well, that's interesting. Why? That's a bug. Okay, I expected that to work. I must have broken something. Yeah, okay, that's if I say 1. Interesting. All right, so one of my regexes are regex in R. So if it is at the start of the string and it is either a left bracket or a left paren or a left curly brace, or it's the dot and a colon, or I just added this, so maybe this is screwy. It's non-white space and a backslash. So did I match that? No. I'm curious. Maybe the node. Does this not work in? Right, so we want to say this. So R equals this. R match echo. So start of the string and then and that matches. Exec. So it matches that, yes. Okay, so now if we say, oh, because this matches a bracket. Yeah, this doesn't match because this matches it. Got it. Okay. Because this is consuming the echo. So what we need to say is I don't know how you say not. JavaScript regex. Match new line. I want to say not. It's not. Okay, so question mark bang, question mark bang, question mark bang, not for space. Can we say space here? No. Space. And then just a dot plus. I think that'll work in here. So if we say, instead of S plus, we say, S plus is non-white space, but if we say question mark bang, and it's not one of these two things, ooh, unmatched friend. Pretty. Start of character. That should not have a quote in it, that backslash. So then match anything that is not a numerous ones of those, blah, blah, blah. No. Why is that no? Because we want a star here. No. Right, this is correct. But this is the last entry in and the first one is this. Right, so that should work. Let me just double check that I did. I know that's ugly. That's super ugly. Usually my regexes are not that ugly, but that is ugly. Right, so it matches any opening brace or a word. I should just use word, right? That's so much simpler. Like that. It's not W, is it? W is not word. W is white space. No, W is word, yeah. Come on, where are the patterns? Character class. Any alphanumeric character from the basic Latin alphabet, including the underscore. Yeah, this is what I want. So W, I just want a word character. So any word, yeah, because you wouldn't want like a, yeah, so word plus and that. Okay. All right, so I think that if I now go back and copy this code again, go to that, this, not node, I want node. YouTube is not receiving. Nothing I can do about that. Hopefully I'm broadcasting here. YouTube is not receiving what? Enough video to maintain smooth streaming. As such, viewers will experience buffering. All right, well, I'm sorry, viewers. Not do anything about that. All right, so let me put this back here. npm, sorry, node, and then it's imp.mjs. Because I'm not in the right directory. Still not good. That works. Oh, okay, now this is a different problem. I actually haven't implemented this. So this should have matched. But then it's going to look for the closer. All right, so where do I use the word closer? Okay, so this expect. So first of all, we start a new node. If closer has own property toke, then let's see. Let close equal that by default. But if otherwise, we override it. So then the closer can be like the idea is that the opener can be like hello, blah blah blah, but not hello this, right? At least for now. Yeah, toke slice -1, is that right? It gives you the last letter. Okay. Actually, that works better because now you can open it with any of these things. But the matcher doesn't actually do this. So we could put this in here. I hadn't really intended for that to be the I definitely intended because I wrote it. Where does it say projection syntax? This is projection syntax. So this is partial application. I guess there's no particular reason why it couldn't have the same kind of thing for the other two braces, the other kinds of braces, which would be this. Come on. I typed what I wanted it to be, but then it auto completed the oh, but if we're doing that, then we could just say and over here we could just say W star. So either some number of word characters followed by one of these openers, or dot colon to create a nested comment, and then the appropriate closer would be the end there, or yeah, that's kind of a weird syntax. You can't put this as the first character in here. You'd have to escape that. Kind of messy. All right, whatever. That should work now. Ooh, still doesn't work. Then, in that case, let's print console.log node and then toke. But maybe better would be to put a print here. Oh, it's including this. It's yeah, so this is matching, this is not matching as a separate token. So that can never be a token. So here what we need to say is not, we need to do what I did earlier, which is question mark bang. Not any of these. And then a dot. So match anything except those. Oh, but it has to be a non-white space character. And then plus sign should apply to this. So anything that is not a white space and not one of those characters. So try again. There we go. All right, so and that should match the whole thing. Oh, see, that's a good challenge. I did not do it myself. That'd be a great little task. If you're using regexes, I mean, probably the better way to do this would be to write it by hand. But I had already been using regexes in this thing, so let's see if this works. Where's the fizzbuzz? I assert that this will produce one line here and then a bunch of dotted lines here to paste. Oh. Yep, so for I in range, yeah, so there's my parser. And this print statement is not, or this printer is not, how would I say it? It's not, I don't know why it doesn't recurse all the way down. Like, I don't know why this as array, maybe there's a limit on how deep it can recurse. Because I'm just telling it to print. I'm just telling Node to print this thing. So I bet Node is saying, once you go down this far, I'm not going to show you all the details because it would make it too big and complicated. I don't know. But my printer is going to do this better. So it won't be in color like this, at least not for now. But it also won't have all this junk. So okay, so first of all, what I want to do is erase all that print junk that I just did. Let's working. We'll take all that out, and we'll take this out, and we will fix this. So we will say, oh, what have I changed? GD readme. Oh, right. So this is where I wanted to change that. I didn't check that in, so I was looking at it. I think this should. Let's see what this does. See what that parser does with this. No. So what my question was, bang 100. Yeah, so it treated this as one symbol. I think probably in the future I want to change that so that you can juxtapose, like you don't need a space in between them. But since the only place that I've ever promised to do it that way is in what is it, for X and I and bang or something? Yeah, so that. I'll just put the space in there. I see someone's watching, by the way, so welcome. And feel free to ask any questions or say if I'm being silly. All right, so this. Oh, and then this one here is also wrong for now. This is definitely going to be a suffix that is possible, as are the primes, the apostrophes, which is each and k, something like a map, maybe something like a width. But yeah, for now, spaces everywhere, except for those limited cases. Probably that's going to go away. And this is clearly wrong. But... all right, so mostly I just wanted to fix this. The word range is going to be the bang sign. Like git add readme.com, or just git commit-m with, you have to escape it, otherwise in bash that'll do something. gd imp core JS. Right. So then what I'm really working on here is fixing the list or the list reader. And right now, if you look at that, I guess I'm trying to keep like the program running, but I guess it doesn't matter because I'm changing it. So if you look at this, you see it makes the brackets, but it doesn't distinguish between what kind it is. And so what I want to do is add an attribute to that. And I think, let's see, does node let me do this? So if x is equal to this, can I say x dot like tag or something equals hello? I can, okay. Oh, no. No, that's not what I want. It's interesting. So it becomes an object with square brackets? Interesting. I would expect that to be an array. I guess it's not. Very interesting. That very much surprises me. Okay, well, it's not what I want either. So I guess my intent was to that the tokens would each have like some annotations on them. So this is going to look a lot like XML, in that we've got a tag, some attributes like where in the source code did that token come from, like the line number and whatnot. But I'm leaving that blank for now. And then I guess here, oh no, this isn't that one. So then for node we have to do the same thing. So we have to push node. So the tree builder itself pushes the token pushes the list onto the stack when we're done. So once we have that, Where would I do this? I think I need to modify tree node to have a token to take the data, to take the attributes that we want. Or no, I could just store it here. So get so node. Can I do it here? Only if I keep a stack of them. Which I do. I have this stack right here, so I could just instead of just pushing the closer, let's put let's push. So break this into a couple lines. We'll push C for closer. What we expect, we'll say T for tag, or say tag is. I take everything but the slice, but the -1. So we say X slice -1 is going to be X, but if we say 0 -1, yes. We say X, yeah. Oh no, that's not right. Oh yeah, that's what I want. ABCD. Everything up to the last bit. Slice 0 -1, and then the closer and then the opener is poke slice -1, the last character. This is going to tell you what to print, and then, or actually maybe. Maybe we just say so tag. Tag is the token, or we just call it token. So the opening token, and then the closer is closer whatever. So then I'll open them because there's a close. So if this is if close toke is equal to X close, this tree done, console. Right, so then, right. So then it's closed properly. We've agreed that it's closed properly, so we're going to close it in the tree builder, and then we're going to take that last item out of this tree here top. Let that equals. Oh, we don't even, we can just modify it in place. No, we can't. We're going to take it out, and then we're going to replace it by emitting T. Yeah, T dot. That's exactly it. That. But we'll put this dictionary that we built up here as the attribute. Okay, so now if I did that right, then when I run this, and I say blah, blah. Yeah, we have a list. It starts with this, it closes with that, it contains nothing. And if we say hello, or like to use a K example, if x greater than 5, x equals, 3. So it does recognize this. Yeah, and now the output is completely broken. So yeah, it just doesn't, the printer here doesn't want to print this. And who can blame it? Who can blame it? It's so deeply nested. But we're going to print it in just a minute. All right, so basically what we've accomplished here after all that work, yes, gd of imp core and imp. I should probably look at all these red files at the bottom. What is all this junk? Junk in there. So I've added list and yeah, okay, so proper parsing for lists and projections. I hate it when Git terminal does this weird thing. I don't know if it's bash or the terminal itself or list and projection. Okay. Midnight here. A little after midnight. Probably not going to be at this too much longer, but I did want to get the pretty printer work, or the, I don't know if it's going to be pretty yet or not, but let's print it out. There's no show here. I thought I had started, on my other laptop, I started a file called show, but I guess I didn't check it. But I didn't get very far anyway. All right, so in the loop here right now, what we do, I don't like this. This is another reason, like I don't like the way JavaScript handles, like everything is async. And I know you can use the async keyword to make it less painful, and you can use promises to make it less painful, but like once you have a virtual machine, you can stop it anytime you want. So you don't need things you don't need a keyword like async. You don't need promises. You just write synchronous code. That's the appeal of Go, communicating sequential processes. If you have multiple processes running and they talk to each other, you can let them run concurrently without all these callbacks and whatnot. Okay, although callbacks are nice in some cases, but you shouldn't have to use them everywhere. Anyway, so I read the thing, I write the prompt. What is causing it to print? I guess this. So imp read returns all right, so let's rename this to imp r. Imp r for the reader. And then we're going to have imp writer from imp write. Hey, how's it going? Ayush? I'm saying your name right? Welcome back. Imp writer. And then we'll make a writer. Writer equals new imp writer, so we have to make a new thing. Maybe we should call it show. Imp show or imp Formatter, printer, does not matter. Imp write.js. I'm doing well. How are you? This should be pretty easy, right? Or it should be less complicated than the other things. We just have write. Let's see, we need a function show, returns a string. Show x, and it's going to return a string. Return a string representation. I don't want to use like a dumper or show or imp show. Let's call it show. Show x, and then we want to import from import. We definitely need the types from imp core. So then, yeah, that's this. See if this works. How about we say type attributes and value equals x. So we have to say let. And then we switch on the type. And then we're going to say the string. If it's a string, we're going to return JSON stringify, right? Because if you say x or v is cat, we want to print it out, JSON stringify v. Yeah, that's what we want. So console log, and then it comes out with just the quotes. If it's a multi-line string, then we will return like that, but probably we want this to be have a new line here, and then new line here even. Yeah. And if it's a list, then we want, okay, so now we have to do this thing. So this show list. Oh, we could say a dot token. Is it a dot toke? Would be a nice place to have an actual type here. But yeah, a dot toke and then close. A dot toke plus v v map this dot show join with spaces and then a dot close, because we saved the token and a close. So token close. We call it open in here. Yeah, and then yeah, we don't do anything. Why is this red? Because it's not attached. Oh, untracked. Something's wrong with the file. I think I have an extra curly brace. Correct. Int string MLS list. Is that it? Int string MLS sim and list. Okay, so then sim. That's actually just B, and it's a symbol, so it's a description. You say V. The symbol type has a symbol X. And you print that out. You want to get that. You say description. You get the value as a string back out of it. So if it's a list, then yeah. So now this is going to work, but it's going to put everything all on one line. But there's no pretty printing here. I'm okay with that for now. So where's my example code? Oh, it didn't work. Toke is not defined at impreader.done. Thought I looked for that. Oh, got close toke. Right? Because I didn't tell it to use the writer. So here in the REPL thing here, we have to say, instead of console log, we'll say console log imp w show imp r.read. So read the thing and then show it and then write it, print it to the console. Reading close. Like, I know I pasted the wrong thing in there, but I would expect this to still work. Although possibly that's what you get if you do that. Yeah, you get close. Array properties of undefined reading close. Okay. So that means we're missing a message here. If not X, if not X, console, yeah, unexpected close token. And else if it should, oh, W show is not a function. Certainly is. No, it isn't, because I didn't say writer. Value of copy and paste. Okay, so that should say unexpected that, and then it throws an error. And probably I should do error handling better, but let's just assume, let's not worry about error handling right now. Right, so now, copy this again. So we actually need to expect the dot open. How about open? Right, because there's a oh, that's wrong. So if you use the comment opener, comments opener, and then closer is open. No, actually, we want the full token. Closer for O. So if it's that, then we keep it the same. Otherwise, we take the last character. Cannot convert a symbol value to a string. That is a symbol. I wonder if it's this. Self equals this. How do you do that? That's a thing I do not know how to. I thought I knew how to do this in JavaScript. Since introducing the class syntax, I don't know how to. Well, do I know how to? I think this should work. This should be right. Ah, no. See what we got here. I've screwed up the structure of no. This should work. Oh, I know what it is. I know what it is, but read. We want to return something other than just this, because now we have to return, we have to put a type signature on this. And so we're going to return the top. Let's call it top. So at the very top level, you're generating a list, and if you type like a multiple, like if you type ABC on one line, it should return a list, but it's like a top level list, like for the entire file, so there's no delimiters on it. And so we need to make a new type. Yep. Top level sequence. No list with no. I guess we could put this on here, but I think like we could consider it a list, but I think since this has delimiters and open and closing tag, this does not, and it might have like a source, like whether it came from a file or a REPL or whatever. So I think it'll have different attributes, so we'll call it something. So yeah, and that's it. Right. So this is because I'm telling it to print it out at each step. So that's what we get at the start, and then it's the top. So we have these three symbols, and we loop through it. So if I just hide this, then we're good. Okay. All right. So I now believe this works. Ooh, shows what I know. Cannot read properties of undefined. Hey. I'm almost positive I know what it is. Do I need to say this? Self equals this. That self equals this, and then we say self.show. Because the value of this is changing, isn't it? Oh, okay. Imp right, line 15. I believe if I say this is going to work. So that doesn't work for different reasons. $15.50. hate this about JavaScript. Like when you made, you could always fix this by saying self equals this, but in a class, why is it not working? Of course it's not working because you have to bind it to, you have the binding of the word this is okay, so JavaScript map this. Yeah, how do you get here? Oh, I bet if I, yeah, I bet if I put it here as well. So let's say recurse. Oh, let recurse equals, that works. Or you can also write it as the map self for this dot show. So let's say we'll call it just, let's say list, or we'll say show list. Show list. And show list equals, we'll say x's map this dot show join. Okay. So this double arrow causes the keyword this to be bound. It captures this, basically captures the this keyword. If I replace this call right here with show list v, and this with show list v. I think when I said v dot map, I think v becomes this, or the specific item in the list becomes this. I don't remember. But if you do that, JavaScript, sometimes it's, I've actually been like, you know, I've got a very short amount of time to build this language because I'm got to go back to work in like April. And oh, you're kidding me. Anyway, you know, like JavaScript was written in like a couple days basically for Netscape, and you know, it worked out pretty good, I guess, but. But it's got some weird things in it. What am I doing wrong? Let's look on Stack Overflow here, because I know what the problem is. I see what the problem is, but I don't. Like it's telling me cannot read properties of undefined. So this is undefined. Trying to read dot show at show list on 739. So at 7 unlock position 39. This dot show. So we could give this a name. Let show equals this dot show. And try that. Yeah. Stupid thing. Ah, so stupid. All right, we still have an error here, so we're expecting something and we got this, so we're comparing it to the wrong thing. But I think here we can just say show x. Just show x as well, right? I'm just curious. I believe you can say that. Yeah, so that worked too. It's a stupid JavaScript thing. I do not understand the design decision inside of JavaScript that causes it to behave that way. Anyway, I'm fine with this. There's probably a better way to do this, but I don't. Doesn't matter. I suppose one way would be to define show itself as this. Let's see if that works. No, interesting. Show is not defined. Oh, but we have to say this dot show. Yeah, that worked as well. All right, so that saves me a line. So maybe there's some way to like do this binding without the arrow functions, but that works. All right, good enough. All right, so this error message is wrong, and that makes me think that the test is wrong as well. So expected x, that should be expect dot close. Oh no, we did check that. So let's see what we got here. Oh, close is undefined. Actually, we want -1. So we want the last character, and that's why. That's right. But okay, so we'll fix that. This is the result of the right, but let's do this. So if I just want to check that error message. Yeah, that's it. Okay, so why is it printing undefined and then fizzbuzz and then dot? Let's see. Could be the ABC. Yeah, I believe this join is correct. Join. Oh, wrong here. Oh, this is not JavaScript. That's what's wrong. That's right. So map this show join, and everything should have a return. Unless we do this string, that's a string, that's a string, that's a string. So where is undefined coming from? The opener is not there because I changed this to word open. This is a type checking thing, like a type checker. If I had a name type for this thing, where is it? Yeah, because I changed it to open. That's what it is. I mean, it's not a big deal. It's just I have to be the type checker. But that's why I say in the description of this language, I like types. I like type annotations. Sometimes I like to start with them. Even if I don't start with them, I like to put them in eventually. Right. I would say that looks about right, except for this the escaping here. So for I in range 100, first of all, that should be a yeah, right. I guess if I refresh this page, that'll change to a exclamation point, right? So that is that part. So we have bracket, if not I mod 15, right? Fizz buzz. F not I mod 5, right? Buzz. F not I mod 3, right? Fizz. Plus right I. If I mod 10, echo. That's okay. Probably the actual code should be echo, like echo should have a parameter. But that's doesn't have anything to do with this parser. I also think maybe OK should be the empty block. Treat it as a program. And then you wouldn't have to put braces around, or circles around, or brackets around it. So I think it would be nice to have. I don't want to track new lines, right? And like the formatting should, like like I'm not trying to make a super fancy pretty printer here. I'm wondering if I can do this in such a way that like one option, one easy option, one extremely easy option is to treat p dot set return return Here's what I'm thinking. Like in K, a new line and a semicolon are kind of the same thing. They're just two different syntaxes for the same thing. And then the pretty printer chooses which one to print. But if you just printed a new line, that would probably be fine. Okay. And then down here, you have a piece of punctuation. And then here you have one of two things. You have either a semicolon or a new line, and then the S makes it a multi-line match. I think actually S just allows the dot to be a multi-line. I think you need this. But not. You say emit T dot set. Yeah. So if I do that, I should get the exact same formatting that I paste in. But I do not. Let's see if we put this here. Do what now? P.sep. Oh, right, because it has to be one or the other. And I don't think you need the S because you're not using a dot. Could be wrong. Still wrong. New line. Let's try this in here. New line or semicolon. Semicolon or new line. It's because this is matching. So we have to say I believe that should work. Well, so I need to put the multi-line thing on here? You have to put the S here? And then here you match the sep. So match not a new line, but otherwise white space. any number of times. Okay, do nothing. Ignore it, ignore white space. Otherwise, match a semicolon or a new line. I expect this to work. I don't expect that to work. I'm probably doing something wrong. I mean, I'm clearly doing something wrong, but probably doing something easy. I got no aha there. I see the trouble. The trouble is that this starts a new line, right? So I need that character there. Or that, I think that trouble, that, no? All right, well, let's figure out how JavaScript, how to match a new line in regex. I should have just not used regex. Oh, maybe I need the M switch. Dot, I don't want dot. I want to explicitly say, explicitly match. That should match. Backslash n should be sufficient here. Maybe the brackets are causing the backslash to be a literal. Try that. And otherwise, I think we might need a flag here. So no aha. So I think we need a flag, and I have the wrong flag. Not quantifiers, groups, and back references, character classes, assertions. No. I'm looking for the forward slash, the thing that goes at the end. Match next to new line characters. Allows to match new line. Sensitive search allows next to new line characters. Okay, so M is the word I want. So if I say M here, I think that works. Let's try it in the, instead of just guessing. Let's try it. So backslash n, does that still work in JavaScript? X. This one? Rx equals this. Rx dot match. And Rx exec. And then we save that. So it works. That works. But if we put this here, that works. Is it possible that the prompt is the prompt library here is stripping out the new line? Let's say send if, or just say console log, what? Console log JSON stringify sent. Nope, it died. What's wrong with that? Doesn't have a colon at the end. Yeah, it strips out the new lines. Well, that's dumb. I guess it's okay. I guess that's what you would want a prompt to do. Hmm. I think that's going to cause problems, but I think it's going to fix this problem but cause another problem. So if we say X, yeah, so we get X and a new line, and we're going to always have that new line at the end. So I would say for that, so it would say if the imp reader is waiting, not waiting, yeah, waiting. So if it's in the middle of something, then we'll send the new line, else send nothing. And that way, on a single line, 2 plus 2, we shouldn't, dang it. There's several flags here. Maybe waiting isn't the one I want. If it's waiting, you return the new line. I think that the logic seems right to me. If it's waiting for that message, meaning if it's waiting for this chunk of code, that means, or the text, then it means that it's inside of a bracket. So if it's waiting, then we want to add a new line character. No. More like this. Like if we're waiting, then we'll send it right here. Then impr send new line. And then prompt. Yeah, no line. That's right. Okay. And there we go. And now it pretty prints by just keeping the formatting. All right, so then the only other thing I want to do is remove the backslashes here. I think this is all correct, except in the parser, like the writer is actually doing JSON stringify. I think that's fine. But in the reader, we need to strip off the quotes, the double quotes. Okay. So here we will say x twice 1 negative 1, right? Expecting, yeah, L. Perfect. All right, so we have a read and print loop. We don't have any evaluation step yet. And it is 1 o'clock here, so I think I'm gonna check this in and call it a night. All this stuff is still, this is not done. The tag is now the opener, right? So we have that. Multi-line strings, we have that. I guess I should test that works. Oh, it does not work. So this does not work yet. And I think I see why. We have to, the prompt is only reading 1 line, so we have to match the unfinished string, and which is the exact same issue as a handle unterminated string. So we have also right, because the buffer that we're building up is going to have, yeah, it's just not going to have that issue. All right, strands of juxtaposed numbers should be a single token, floats, blah 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 blah. And this would also be a lot different if I were reading from a file, because then I would have like line numbers and everything. I would be able to track those line numbers. Oh, and then so like have nums as a token. Like that wouldn't be too hard to do here. I'm just not going to worry about that right now. I'm going to clean up what I have here, and just like it's fine for that to be. So let's see, 1, 2, 1, 2, 3, 4, 5, 6, 7. This would expect 3 separate symbols. 4 separate symbols. Yeah. Oh, but it's a string. No. This is garbage. This is just printing the string that I got sent. So then sent here, we just hide this. Press sent. Hide this. And okay, that worked. This is very liberal, so you should be able to send just about anything to it and get back. This is not quite right. This should actually match spaces inside. So like once you get this, you should be in a different mode here. Where it would match all the white space and all the. It's still matching tokens inside of that. So I'll work on that later. This aha needs to go away. That's just a bug statement. But where was it? Here. 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 It's in the very bottom where I match that token. Where I match the separator. And so then we're also going to match double check that this still works. See, now I've lost the like the debug part of this. Yeah, so that one is like kind of bound to the whatever. That's fine. I've lost the thing that actually shows me the tokens. So even though I'm printing out the round trip of it, 1, 2, F, 3, that space should go away. Yeah, that's all good. Okay, it's not perfect, but it's good enough for tonight. So what have I done? Okay, so I'm adding the writer. Git add. What else have I done? GD imp core. Yes, I added top and sep. GD imp read MJS. I'm just gonna add all this together. Git add imp core. Git add imp core imp read and imp.mjs. And we're gonna say git commit. Oh, I have to add git add imp write now. What else is down here? Eval is not good yet. This should be just get ignored. We'll clean all that. Clean all that stuff up later. It's hot in here. It's actually supposed to have a blizzard outside, but it's like burning up in here from all the lights. So what have we done? Basically, add write loop, add formatter, add unparser, and fix some part and fix it. This would really be multiple commits. Not going to worry about it right now. This is a first trip down the trail, right? I'm going to start adding tests here now. Like once I have the start on the evaluator, I'm going to have some tests here, and probably I'll go back and redo what I've just done, like as a test suite as well, because obviously you're going to have to implement. This course about building this language, right? I got to go first and then prepare the the language for the students. So when I do that, that'll be step by step. All right. Yeah. Somewhat tempted to see if any of this works. I think it should. Like, I think this should probably work. Yeah, that works. I mean, it should come out okay. Is what I'm getting at. Like, all of that should come out okay. Basically, anything you throw at this thing should come out okay, but it might not be in the right set of tokens that you would want it to be. And so the next thing to do, oh, I've got an unexpected error here. So that didn't work. Even though those are balanced, something didn't. I think probably I don't know. Doesn't matter. Something's wrong. See if this one works. Yep. I figured that would be some issues. I'm not sure why it's broken. Maybe because all of this is being... No? Oh, maybe all of this is... I don't know. Yeah. Okay, that's kind of encouraging, though, that all the other things parsed. I'm not sure that this is going to be canonical. This started out as K, and then it... I'm not sure all these K functions are going to carry over, but we'll see. Getting this to print out in color might be nice. That wouldn't be too hard to do with by marking this up a little bit. But like I said, I'm not going to worry about that tonight. I think everything's checked in. So just double check. Yeah, everything's checked in. So I will call it a night. It is 1-something in the morning. So thanks everybody for watching. Stay tuned. There will be more of this. And there will be a language that you can download pretty soon and try out. And as you see, as I said on the site, it's going to run pretty much everywhere. So I expect this thing to be useful, like not just for the course, but like actually going to be useful as an interesting language to learn and to have in your toolkit to just do quick prototyping of stuff. And I think this is going to be neat. I've been thinking about this for a long time. I think there's going to be some good stuff in here. So stay tuned, and thanks for watching, and I will see you again soon.